Be streaming. Yeah, so I have some Legos. I also have. I should get the part replacing this god awful screw terminal behemoth that came with my Voron kit. It has a PCB that goes between your live, your neutral, and your frame ground, and I don't like it. It's just a bad solution, frankly. I mean, yeah, make a custom PCB. Maybe it is cheaper than just sending a whole bunch of Legos along, but just send me some Legos and like a DIN mount for Legos, and that's just gonna be better. So I don't want to deal with. I think they specified a minimum gauge size of 18, and these will go up to 12. So I'm probably gonna get some bigger conductors and wire the thing myself because, frankly, I would rather crimp ferrules on than use screw terminals because Legos are just better. They're easier to use. It's gonna be. Ooh, I am really loud. Um, I'll leave that and tweak this a little bit. There we go. Okay. Yeah, that's more reasonable. Um, it's just kind of silly to not use Legos, in my opinion. So I'm going to just quickly model this up, go find a picture of some DIN rail or some dimensions of DIN rail as a reference, and then wonder why that window is getting in the way of my other windows. Yeah, should be pretty quick. Let me go find some music. So I kind of want to play Ichika because somebody played that recently at a party I was at. It was very good, but and he is good, but that's probably gonna get copyright struck. Not that that really matters. So, whoops, don't want out loud. Just want. Yeah, okay, that's pretty good modeling background music. So, I switch headphones because the ones that I have in now do not deafen the fact that I have my dryer running in the background. So, and you might be able to hear that, and I don't want that for you. So, do a quick switch here, turn these on, other headphones go away, more headphones plug in. You can't just have one pair of headphones plugged in at one time. I think that would be silly and easy. Where's the plug in? There we go. Okay. Yes, alright. I can still hear music, and I cannot hear the dryer. Alrighty, so I have a WAGO in my hand, and the first thing we're going to do is hop onto a quick millimeter part and do a quick search for DIN rail dimensions. I'm pretty sure it's going to be like a millimeter thick and just 35 millimeter spacing on the ends, but it's good to have pictures, so 1.5 mil. Okay, 35 millimeter on the outside. I should probably make sure. I don't know if it's going to show my main screen if I switch to the screen. Oh, it's just this blank stuff. That's fine. This is the kit that I got from Formbot, or maybe this 3D Printers Bay one. DIN rail. Yeah. Okay. So they don't say which side's DIN rail, so we're just going to assume 35 is good enough. And if it's wrong, then I just correct it later and assume that it's. I mean, I could go measure it. I have calipers. Let's not be stupid about this. All right, confirmed. 35 millimeters. Oh, wait. Stream's bitrate is complaining. We got people viewing. Oh, hi, Dad. Welcome. Okay. Gray now, space. Hopefully it's coming through clear on my side, but I guess I should double check and make sure that it's. Come on, pick the right stream. Stream's current bitrate is lower than the recommended bitrate. Gosh dang it, I had this problem last time. And, let's try a variable bitrate, target 5000. This might break things. Yeah. Okay, well, it's only 1080p. I'm not really that worried about it, so we're just gonna kind of roll with it. 35 millimeter, millimeter and a half thick. Or, no, I guess only a millimeter thick. I only have... How much do I have to work with? So hypothetically 8 millimeters, so let's say I only have like 3 millimeters to work with. So we'll quickly whip in on the front plane. Well, let's do this. How do I want this part to be oriented? Dims. How wide are these things? 18.6 millimeters. We're gonna do right plane. Just real quick here. Be extra lazy. Oops. Make that guy thick. Actually, wait. I want to get rid of this one down here. I'm going to offset 0.5. Cap ends with lines. Cool. Make that guy construction line. Then quickly mirror. Now I can drag this down here. Get my dims up real quick. 35. Whoops. Come on, that's silly. 35. 27. I should not have closed that earlier sheet of dimensions. 15. Is that really that tall? Oh, 7.5 is the low profile stuff, which I think is what I have. So, that's looking more correct. Yeah. So we'll call this the in real reference sketch. Yeah, that looks about right. It's close enough. So now, these little guys are 18.07. We'll say 18.1 to account for, you know, manufacturing printing tolerances. Yeah, basically 18.1. And they are 8.03. 8 and a bit, so like 8.1 millimeters tall. So now let's go same thing to the right plane. Let's do the 3-point rectangle and just quickly give these thickness 8.1 and oh, I said these things are what, 18.1 long? Yeah, 18.1. 18.1. Drag this over here. Nope, okay, can't rotate that right now. I think I can linear sketch pattern this. Let's try that. I'm going to use a quick extra sketch line reference here. I need to make sure that the tip of this one always clears the like when the lever comes up, there's an arm that comes up like this. I need to make sure that the base of the next one clears. So I'm going to draw some control lines here to give myself a Alt-E to make that parallel, Alt-H to make that horizontal, and then I need this line to be like, so we've got this distance right here, and that is roughly how far we need to clear. So it can't be any closer than that. That's about 3 millimeters. We'll say like no more than a millimeter of overlap. And yeah, that seems about right. And I think I'll put this guy in like the middle somewhere. Why is this all goofy? Oh, because I haven't controlled how thick that is. Oops. Say 4 millimeters separation? Like 2, I suppose? I have to locate this somehow, so I'm just going to locate this guy vertically. Whoop! That's all kinds of wrong. Oh boy. That's really goofy. We'll say this corner is 5 millimeters above the face. I think that will give me like a nice reference edge there. Okay. Yeah, that works. Yeah, so we'll just... Actually, there's no reason not to make this guy full width right now. 18.5 millimeters across. 2.5, mid-plane. Got a shape. Let's do front plane. Oh, hang on. I need to pull a dimension out of this guy. This is my patterning length. pattern name length. So now we do exit out of the sketch, features, if I can remember what the pattern thing is. I cannot remember what linear pattern is. Just gonna search for it up here with the S key. So direction 1, I'm just gonna do, actually rather than selecting the front plane, I'm gonna pick, go this and then use this line, just because why not really. I wonder if it'll let me use that for both. It will, that's nice. Pattern seed only so that it doesn't create extra copies. Spacing and instances, make this equal to pattern length at sketch 2. That is a valid value. Only 2. Spacing and instances. I think I need to make sure that's going in a different direction. Oh, whoops. Forgot to pattern the bodies. Hey, there we go. That looks about right. Let's give this guy some solidity too. Make him like 50 millimeters long. Yeah, okay. That looks about right. Hang on, that's not right. That's not right at all. Shoot. Wait. You gotta come back here to the... This is the WAGO reference sketch. Okay. So... Dryer being done? It's still running for some reason. When did I fix this angle? Okay. Oh, hang on. This should be a driven dimension. That's silly. Okay. This needs to be a millimeter long, and this needs to be the same length. Oh, wait, but that... I'm a goofus. That line doesn't exist because these 2 points connect when those 2 contact. So this becomes our 1 millimeter point. These 2 match. We make a parallelogram, sort of by default. This becomes our 2 millimeter thickness. Or, come on, 2 millimeter thickness, thank you. Make the sketch. And we rebuild a couple of times, and we wonder why things aren't working. That is, why is that not patterning correctly? Oh, it's because this isn't set to length at sketch 2. Oh. We go reference sketch, and I'm going to copy all that and paste that there as well. Rebuild. There we go. WAGO's all stood in the right spot. That seems honestly about right. That gives me... Let's see, do I want to stand those up a little more? Maybe 10. Build. Because that'll definitely... I won't have enough clearance to stick individual wires in, because wires from the ones above them will be in the way. Is that fine? That's probably fine. I don't actually care all that much about... Okay, if I make this not driven, and I just delete these 2, and I specify some angle here. Okay, I don't need all this. Yeah. If I just specify an angle, say I want these at 45 degrees, and then realize that I accidentally deleted it in there. Say I want these 30 millimeters apart. That looks about right. Like, that gives me enough clearance for each lever underneath. I mean, it won't be reaching Nuance 5 anyway, so it's not really that big a deal, but... like this? Do I hate it? How am I going to install it? I do kind of want it to be centered, but I still need to have some way to... Let's bring this into like maybe 25. How does that look? Also, I shouldn't be doing this pattern. I should be coming in here. Oops. Manage equations. All these guys are broken now. That's fine. Shoot. Oops. No, come on. I'm just going to do this a somewhat more sane way. Equal and parallel. Make all this stuff equal. Let's see. That one's not equal yet. Add another line over here. Make these equal and linear. Boink. Exit sketch and rebuild anyway. It's going to complain because I suddenly have multiple contours. Tell it all three of them, please. Thank you. Easy peasy. Okay. Now I don't have an extra feature and it's all controlled in one spot. I can see it in this sketch, which is nice. So, everything's down to like 5 millimeters? Or I was already at 25? 22? 22 gets a little tight. 25 seems a little more right. I'm also going to move... Hang on, which order did I do this in? Okay. I think I want... I don't think I want it centered. I think I want to bring this over a little bit so that I have room to reach down so that this end can hook and this end can be accessible with a screwdriver to make the flexure so that we can open it. I think that makes the most sense. So I'm going to draw a line, just dimension, still like 10. That's maybe a little tight. 15. Yeah, that looks okay. That doesn't. Now if I hold it up in front of my eyeball. Yeah, that seems okay. Literally just holding the thing in front of my eyeball in space. So, let me quickly save this out somewhere. Build. Oh wait, no, this gets a proper full-on radio part number because it is going to be. Oops. Where's the right projects folder? Here we go. Yeah. 24012 for myself. Go. It's like a 4. It's a 221413, I think. 35mm DIN rail mount. I'm going to copy that very long name. It's going to go there. It shows up here. WAGO 221413 35mm DIN rail mount. So I've got a reference DIN rail. We've got a reference WAGOs. I think that's everything. Okay, so I'm going to start with, let's make kind of a flexure up here. So we're just going to quickly draw up a little, well, this is going to be a very complicated single part, so I should probably think a little bit about how I do each stage. Whoops. Let's do this. This is going to be, where's my offset tool? Offset verse 0.5 seems about right. How much lip do we need? Not that much lip. 1.5 is about right. Features, extruded. Mid plane. Not merge results. In fact, what I'm going to do is I'm going to hide these first three, all these extra bodies, and just show the sketches instead. In fact, I don't even think I really need the bodies. I'll suppress those for now. Which means I also have to change... Oh, hang on. It's got to reference the sketch instead of the... It has to reference the sketch instead of the body, otherwise it won't be happy. So, put this, delete all this, something quick so it's happy, suppress this, edit this, get rid of that. This is very much a roundabout way of doing this, but I realized I'd rather work with sketches as the reference features, so. 5, and outline, reverse, cap ends with lines. Okay. Extrude equals width. And if I do that, then I will have a width here that I can then drive later based on which size of WAGO connector I'm using. Because the 3-panel ones are 18.1 millimeters across, but there's other sizes too, so maybe I want to make one that's standard for every size. Okay. How chunky do I want to make the... same thing, right plane. I want to just pop it in. I guess there's no reason I couldn't make them slide in from the side. So let's just do that. This will have some thickness to it. This will come down to some distance underneath. Up and over. It's perfect. Whoop. Ah! That was weird. Let's see, this can only be... This has a very limited height because there's a lip on the bottom of these guys that I cannot exceed. Otherwise I will get in the way of conductors. So that can only be 0.6. So this will be... doesn't actually need to be that thick. 2 millimeters is probably enough. And this one can be no more than, let's say 2 millimeters. Same thing. Well, not same thing. Yeah, because we have to avoid the, you know, we have to only touch this space behind the little guy. So make this, I don't know, 2 millimeters is probably enough. Make it extend 3 millimeters below. Say that's probably good enough, but I will see if I can do a linear sketch pattern. This. Do not dimension the X spacing, display the instance count. Whoops. I forgot to select sketch items. Everything here. Variables with point. Whoops, I did blind instead of midplane. Blind and... Oh, the other one I did blind too. Whoops. I'm gonna fix that in the other one. Midplane. Okay, so there's some of our feature set. This covers holding the things and at least the fixed side of the mount rail. So now I need a little flexure to form our clip on the bottom. And how do I want to do that? I have kind of a fun idea. Let's make it kind of a long one, because it annoys me when they're like, I mean, I'm okay with it being a little bit floppy, I guess is what I'm saying. And I should probably also make it so that it's this bit is 1.5, but this one needs to be not vertical because it needs to slope back some so we can rock it on. Rock on, and things of this nature. Come up here, do a quick little U-turn, come back down here. That's going to be really tight, but that's fine. What's this distance? Millimeter? That's probably good enough. Add a quick point and line, so I can make that 45. We can use this to tune how stiff the flexure is. I will need I'll need enough space to get a screwdriver, like a really crummy regular screwdriver, in there. And this thing is 4 millimeters thick, roughly, at the narrow bit. But at the very tip, it's down to only like 1.5 millimeters. So I want a pocket. I want a pocket here with some slant out to capture sort of where I'm. Yeah, sort of like that. This guy can come up and form the rest of the. This guy already is parallel to that. What else is he parallel to? How thick do I want that to be? Do I want the flexure to be just there? Not really. What if I got sillier with it? What if I did... What if I did... Came up like this. At our original 45-degree angle. Said... You are going to be a great big circle. That's going to be extra silly. Up here. Because at some point we have to have like our controlled flexure section, right? So offset. Oops. Nope, not the chain, please. I'll just do this with regular arcs. Do some trimming here. Make those tangent, make these guys concentric. Add some extra stuff over here. Well, I don't know where I'm going to add that yet, where I'm going to terminate that. So I'll just make these guys coincident with that so that I have like a radius point I can control. And then I can make this, let's see, I say 2 millimeters deep. I'll make it like 2 millimeters, and maybe this is 6 millimeters. Say it's going to have some minimum clearance distance from here. 2 millimeters. This can be no more than 3 millimeters thick. This guy has to be 1 millimeter of draft back. What else is controlling this? Oh, thickness. Oh, he's singing now. That's comfy. Let's see, this is going to be 2 millimeters thin enough? Probably. Let's do a quick control of this draft angle here. 15 degrees is probably enough. Because I'm going to have... Oh, this has to be high enough that... hang on. Bring a line up here as construction, and then use... Let's be slightly fancier about this, actually. Because why not be slightly fancy about things? I want to have like a filleted end section up here. And this is going to be our thickness extra plane to make this extra safe, so that it won't break. And I can add a 45 there to control where that sits. Add a minimum thickness here. Actually, I think this guy doesn't need to be perpendicular to that. He can be parallel to this. He can save a little bit of plastic. Hang on. That was just a length there. Let's do something extra silly. Make make these two tangent to control that. That works. And now I dimension in here and make that like 5 millimeters or something to control this position. I think let's bring this guy back down here as the end. That tangent. I don't remember what I used this line for. I think that was my bottom reference. So maybe I'll use that just as the sort of continuing end point for all this. Oh no, but this has to be only the thickness of the screwdriver. So let's not do that. Can I make that coincident there? Okay, and now I can control the inner radius in here to control my flexuriness. And make it a little smaller. I mean, this is a really gross way of doing this, but I'm just kind of throwing stuff at the wall here. So we should be manifold without... Yeah, okay. Boss extrude, blind... Oh, hang on. If I want this to be planar with the backside, I also have to do some other stuff. Hang on. I can't do these mid-plane. I have to do them one-directional because that way it gives me an easy reference surface from the right plane for everything. So we're going to switch these guys back to blind. And this guy is going to become a blind extrusion of approximately the width of a screwdriver, which, to my mind, or to my measurement rather, comes out to about 10 millimeters. So why is it saying this needs to be a thin feature? It should not be a thin feature. Ah, because this is coincident there instead of coincident there. 10 millimeters. Yeah, that looks okay. Not the silliest thing I've ever designed. Possibly getting there, but, you know. So now we come back to the right plane and do one great big fugly join this all together with a big ugly block. Why is that not... Wait, what? Thought I made that tangent. Oh, no, I just made that vertical. Okay. Okay, so I have to delete that. And I have to do this to make this tangent over here and make that happy. Make that parallel, make everyone happy. There we go. Okay. Let's grab this point because he already exists. And a point up here. Make you collinear. Say features, extruded. Global variables width. Keeps going the annoying direction. And that is going to be a chunky part, but that is fine. What happens if I bring this down a little? Does it break everything? It doesn't! It doesn't break everything! Isn't that a novelty? I'm so used to that just horribly breaking. Ah, but that broke. Hang on. Shrink! How am I controlling that right now? 45 there? Let's bring this up to, like, 75. Make that a little smaller. Or, let's do the actually smart thing and come back here, and instead of using that to define the length, we define the length of our flexure first. Move some dimensions out so I can actually read things. 45 controls our position back here for really no other reason than because that's convenient. This is 6 because it was also convenient. I can bring it down to like 4 or something because it just doesn't need to be that big. let's use a dimension here. Say that's gonna be like 10 millimeters. And that puts all the flexure length in kind of this spot, which I think I'm okay with. Check my minimums here. Minimum distance, 1.9 millimeters, that's fine. I'm okay with that. Now, I think I want a little bit of corner relief. So I'm going to come... I'll just do it from this plane, actually. Do a feature... I wish I had an easy way to do corner reliefs, but I guess I kind of don't. Hole Wizard. Let's just throw Hole Wizard at this. We're going to do drilled holes, asymmetric, dowel holes, or actually drill sizes. And pick like 0.5 millimeter. Ooh, I can hide these now because I don't need them anymore. Is that going to hold on there? I have no idea. We're going to find out. It's going to be fun. Hole Wizard. Positions. This face. There. 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 I hope this plays nice afterwards, because I kind of don't have any idea if it's going to. But I have this sort of silly idea where maybe I can just generate all these, and it'll drill those holes all the way down. I'll be like, yeah, up to next, that looks fine. And now I can come back here with a fillet tool. Oop, still in face fillet mode from when I was tinkering earlier. I can click this and say, between right feature and part, left feature and part. Let's do left feature and part. That's going to add a whole bunch of extra faces. That's kind of overkill, but it is gently amusing. These faces go planar. They're off by some weird non-round number. That's awful. Oh gosh. Huh. How do I sketch that? Can I do that with coplanarity? Let's do this. Let's make these collinear. And just be a little bit gross and hope nobody looks. That ends up being 2.4 and a bit. But then I can do this really cool trick where I just delete faces. That's such a gross way to do that. But SolidWorks fills it in, and then you got a part. So, hey, that works. Kinda. It's gross, and you shouldn't do it, but it does work. Yeah, looks okay. Let's do... Before we do that and the fillet... Well, let's bring the fillet down to the end. Do it before the fillet. Actually, let's move before the hole as well. And let's do... Let's do a sketch on this. We'll convert everything on here. Then do a quick peek back at my... Yeah, this one. Grab these two, convert them, and trim all this stuff off in here. So that gets me my extra solid bits. And we will extrude this out 1 millimeter. Merge result. And hide that. I'm going to actually rename some things. So this was the DIN-rail interface, or DIN-rail fixed corner extrusion. This is the WAGO interface extrusion. Actually, extrude. I don't know why I like extrude better than extrusion as a name, but it just feels more appropriate. This is the screwdriver release flexure extrude. This is the unify all solids extrude. Empty volume extrude. Or wait. Remove empty volume A. Copy that. This is remove empty volume B. We're going to put this in the folder features that are sins, because I shouldn't do them and I'm going to do them anyway. That's an okay little pocket there, and it'll print in this orientation just fine. Let's add a quick fillet back here to like 10 millimeters or something. This is the what do I want to call this? This is the base flat, I guess. Oh, printing plane solid extrude. Oh, printing plane web extrude, because this is going to end up looking like kind of a web on the backside. And then this is the fixed edge backside fillet. This is the Dinrail fixed edge rather than the fixed corner, because it's, you know, capturing an edge in there. What else? I need to... Oh! From the right plane. Another quick sketch. Oops. We're going to quickly capture these three edges, and I'm going to be lazy about it rather than doing it from the sketch, because no real rules. Going to come back here. I'm going to add a sketch line up here that'll just make equivalent length to this or something. Whoops. Come on. Equivalent length to this. And tangent. And then my favorite way of controlling how these come out is with this tangency constraint, so that I can sort of pick how much sort of side solid I have along the edge of along the edge here, which is very difficult to see because the camera is very small. But that honestly might not be enough. I might just make that... Okay, yeah, I'm going to do something different. I don't like that. So we're going to do this as a sequence of 3 arcs, I think? Yeah, do this as a sequence of 3 arcs, and we'll make this tangent up here, tangent up here. Take these tangent... Whoop, that's gross. Pick these two, make them equal, and like 1 millimeter. Oh gosh. Yeah, okay, now they'll be tangent without pitching a fit. Make this guy like 50 or something. And now, linear sketch pattern. Just pick a random edge because I'm lazy. Bad modeling practices. And I forgot to pick the freaking edges again. 3, pick an edge rather than the x-axis, just for safety's sake. Oops, not that entity, please. This entity. And don't need an edge selected for that. What? Keeps not generating my freaking lines. Come on. Yeah, that's what I want. Thank you. Get over here. Features, extruded. We'll do up to surface because that lets that earlier extrude control the thickness of everything. And yeah, that's our sockets. So now the hole is going to break because it's going to be from somewhere that doesn't exist anymore. Okay, we're going to flip this around and do edit sketch plane and put it over there. And, oh, I forgot the points don't even exist anymore. So I have to regenerate the points anyway. Whoops. That's fine. You could do this with patterning, but it would take me longer to remember how to do it nicely with patterning than it would to do it the nice way. So we're going to do it the lazy way. And all the edges are missing. That's just fine. Fillet's broken. Do fillet. Is there a fillet on the edge of these? big enough one that I want to rely on it, so. Well, it's like 0.4. Pick this and go right feature and left feature. Left feature, right feature. Left feature and part. Ew. Oh, okay. Can I just pick full feature? Oh, darn. Guess I can't. There's gotta be like a nice way to... Okay, I think this will involve less deselecting of edges than any of the other options, so I'm gonna go with this one. Oh, gosh, if I don't manage to accidentally double select a bunch of edges in the meantime. I think I got everything, but it's still complaining. Why is it complaining? Ah, that is right there probably. Yeah, there we go. Cool. I don't know if that was faster. It probably wasn't. But there's your edge reliefs. We can actually bump that up to like 1 millimeter or something. Well, oh no, we can't because we have to keep that edge to keep things fixed in place. Although honestly, being captured in 4 corners is probably going to be enough. Let's see if I can't throw a quick chamfer on the inside of those. If I can remember how to call out a chamfer. Thank you. Just a wee little one. Not sure it likes doing that. Yeah, it kind of doesn't like doing that, but it will make them easy to put in, so I'm going to do it. What is left? That's honestly kind of low. I might want to raise that up a little bit, move it over. Yeah, let's 7.5 and also 12.5. Bring it over a little. This kind of needs to fill it in here. Just something to make it less terrible. That looks bad. Don't like that. But if I don't look at it, it's not real, and it can't hurt me. I may also... Hang on. Yeah. What made these edges? Is it this? Oh, sorry, no, it's the WAGO reference. Let's bring this over a little more. Rebuild. And make that a little thicker. At like 3 millimeters. That makes me feel less bad. It looks a lot better. Yeah, I think that's basically good to go. I'll probably clean this up a little bit. Let's do one more really lazy... Oh, sorry, I forgot. WAGO Pocket Back Web. WAGO Pocket Hinting Face Web. This is the WAGO Pocket Corner Relief Fillet. This is the WAGO Entrance, or WAGO Pocket Entrance Chamfer. This is complicated. Can I do this with one fillet feature? Is it going to complain because these two are intersecting? It will complain because those two are intersecting. Okay. This is actually doable immediately after the release... No, it's not doable after the release flexure. Why can't I do it after the release flexure? Oh, because the release flexure is before I unify everything. So, let's see. Get a quick sense of the feature grouping here. Interface, flexure. So this is the base solid extrude features. These are... Is this the WAGO references? No, this is the DIN rail reference extrude. which I honestly am just going to get rid of. Don't need those. Having these as hidden and having them as the reference sketches folder. Features that are sins because they are bad and they should not exist. They can stay like that. That fixed edge backside fillet is just a... You can go all... Nope. Why can't you go up there? Oh, because it goes after the web, maybe? Why can't I go before the remove empty volumes? Whatever. I'm not going to touch that. It's the printing face web. This is the... Yeah. Extrude the backside fillet. And then this is the... we'll call this the flexure cleanup fillet A. Flexure cleanup fillet B. Okay. And that seems like it'll be flexy enough. Actually, I might make it a little bit smaller. The dryer just made a noise I wasn't expecting. Suspicious. 1.8. 1.6. Yeah. Oh! You know what I just realized? I should make sure that this is actually, rather than having this reference the DIN rail exactly, I should make this be on that line, and it should be like 0.4 millimeters higher. That's what it should be. So that we have some actual by default compression on there. That would be kind of smart. And I think this is probably too steep. So I'm gonna bring this back to like 0.8. And this back to like 0.8. Or maybe not even that much. Maybe control this with an angle over here. Like 50 degrees. That might be too tight. 0.2. That looks about right. I think I'll be able to snap that on. It just, by default, it should have a little bit of compression on it, otherwise I'm screwing myself, so. Yeah, that's... We're almost there. I think there's like a couple of extra things I should probably add. So these are WAGO pocket relief features. And I think the only other thing that I want to do is clean this up a little. Yeah, let's do a quick message from a friend that's possibly urgent. A friend is asking if he can leave plants in my house, to which the only correct answer is yes. Let's get real lazy with it. Let's do just a copy some edges here. Do this. And make an arc. Say be tangent there. Be perpendicular to that. And then you should be oh no, you shouldn't be. Or no, you should be concentric with that because that'll be right in the corner. And then is that thick enough? Am I happy about that? If I say extruded cut up to next, yeah. And I think I can come back and fix that with the WAGO interface. Just say make this 3. Yeah. That looks nice and consistent. That is basically a finished part. I don't feel bad about printing this, I don't think. I will probably add an extra cleanup fillet there. Call this the flexure cleanup fillet. Flexure and cleanup fillet C. Flexure cleanup fillet C. How long have I been going? Oh, just under an hour. Not bad. Um, yeah, I think I think that'll work, actually. This is a little funny that that doesn't extend all the way up, but I kind of don't really care about that. Like, that's sort of fine. It's just a printability thing, so. And this is going to end up being mostly hollow. I'll probably print 2 or 3 of these, or just one for kicks. You know what? Let's do that, actually. Let's see how... Save out as an STL. Save. Would you like to make a big binary? I would. Oops. Where'd that folder go? Come on. Pop open Super Slicer. Alright. Oops, wrong face. Whoops. Let's rotate this back upright, and then do this from the right face the first time. See, this part is such a funny part that I kind of don't know what orientation I want to start it in. This seems kind of fine. Print in an hour? Which infill and walls are we dealing with? Pretty empty. That looks like a pretty good... Yeah. I'm okay with this. I think I might chop down the walls one, because that's most of our time. So we'll go over to print settings, perimeters, kick that down one, slice it. Saved 5 minutes. I'm just gonna keep the 4. I think that doesn't save me enough time to really be worth it. So, yeah, that's it. That's part designed from scratch. Pretty pleased with how that came out. I think there's finesse and things I can do to make this part look a little bit nicer. But honestly, it's gonna do its job just fine. You could add like weight savings holes past that. I mean, that wouldn't even save time, because most of our time is going to be spent printing the perimeters anyway, so it's just what it is. Yeah, if you're watching this after the fact, thanks for doing so. Like, subscribe, all that fun stuff. You know what to do. Hopefully I'll get to see this part in an hour or so. I'm going to use all of 12 grams of filament, and it looks like I have probably about that much left on the spool, so... yeah. Have a good morning, afternoon.